Welcome, geometry students, to class today on this Tuesday, May 6th. Hope you guys are doing well. Hope you're ready to learn some math today. Let's quickly do a review of what we studied yesterday. And so here we go. We looked at two theorems yesterday. The first theorem that we looked at, it says if the diameter of a circle, let me fix my pen here real quick. If the diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So basically what we said is this. If I have a diameter of a circle, and there's the center, and it is perpendicular. So if I have a diameter and a chord, and they're perpendicular. Let me say that again. If I have a diameter and a chord and they're perpendicular, then this segment from here to here will be congruent to this segment from here to here. Or in other words, we can put one mark here and one mark here. And the arc that goes from here to here will be congruent to the arc that goes from here to here. Or in other words, I can put 2 marks on this arc and 2 marks here. We also studied, well, here's a couple problems. So we saw that you should be able to solve problems like this, where you have a diameter and a chord, a diameter and a chord, and they're perpendicular, and you should be able to find lengths of these segments here or these arcs. Okay, moving on, we also looked at a theorem yesterday excuse me, that states if one chord is a perpendicular bisector of another chord, then the first chord is a diameter. So in other words, if we have a circle like this, all right, and if we have a chord that runs this way and a chord that runs this way, so here's what we have. If you have two chords that intersect, got it? If you have two chords that intersect and they're perpendicular and this segment here is congruent to this segment here, then you can state for sure that segment AB, the segment that's doing the bisecting, is a diameter. Okay? And that's basically it with yesterday's review. So that's what we learned yesterday. Make sure you're grasping these concepts, students. Make sure you're working hard. I'm trying to go slow. If you've noticed, this video today is very short. I'm trying to be very reasonable this last week and a half of school and teach you and make you learn, but not be overbearing. Okay, so let's work hard and let's finish up this last week to a week and a half, really working hard. Now today we are going to finish lesson 11.4. We will be looking at one theorem dealing with chords and arcs. Okay? Your heading today is properties of chords and arcs, and I'd like you to keep track of the date. If you don't mind, the date today is May 6th. May 6th. The lesson number is 11.4. Here is the theorem. Now I want to warn you, the theorem is not going to make a lot of sense, but I'm going to explain it with a picture, a couple of diagrams here and there to help you, okay? But here we go. In the same circle or in congruent circles, either way, and then you have two parts. If two chords are congruent, then their corresponding minor arcs are congruent. And then it says it backwards. Okay, here's the converse. If two minor arcs are congruent, then their corresponding chords are congruent. Now let me give you a picture of this, and I think it'd be very wise to take some really good notes on this, okay? So here we go. Go ahead and draw a circle in your notes, and then I'm going to go ahead and I'm going to draw a chord right here, and I'm going to draw a chord right here. Now, probably what we need to do, to be honest with you, is get two circles drawn. Let me pull this over here, and you'll see why in a second. Let me draw, and I'll just go ahead and do this real quick here. And my neighbor just started mowing his lawn. I hope you can't, I don't want to shut the window. I hope you guys are not being bothered by that. I'll try to talk really loud. But anyways, here we go. Moving on. Let's go ahead and draw pretty much the same thing. So I'm going to draw a chord like this and a chord like this. Okay, now part number one right here. If two chords are congruent, so I'm going to go ahead and put a slash here and a slash here. If two chords are congruent, then their corresponding minor arcs are congruent. Now please listen. Do you see this chord here? Good. Do you see this chord here? Good. Here is the minor arc for this chord right here, this chord right here. Here's the minor arc right here. It goes from this endpoint to this endpoint on the circle. The minor arc for this chord goes from this endpoint here to this endpoint here. Are you ready? Here it is. If two chords are congruent, then you know immediately that their two minor arcs are also congruent. That's really helpful. So if a chord and a chord drawn in the same circle, or if they're drawn in congruent circles, if a chord is congruent to a chord, then you can say their minor arcs are also congruent. Now you know what we're going to do over here, don't you, students? Now we're going to do the opposite. We're going to say the chord, we're going to say the arc. Sorry. I hope I said it right over here. If two chords are congruent, then their corresponding minor arcs are congruent. Now over here, I'm going to go ahead and say that this arc right here and this arc right here, I'm going to go ahead and say right now they're congruent. So one mark here and one mark here. Now look at part two. What does it say? If two minor arcs are congruent, like I have here and here, then their corresponding chords are congruent. So if I know this arc here is congruent to this arc here, then I know for sure that this chord here is congruent to this chord here. So if you have two congruent chords, their minor arcs are congruent. If you have two minor arcs that are congruent, then their chords, corresponding chords, are congruent. Okay? If two chords are congruent, their arcs are congruent. If two arcs are congruent, their chords are congruent. And now, having explained that, let's look at three problems and then we're finished. If you would like to write in your notebook, page 610, 3 through 5 in the middle of the page, that would be fine. Or you can copy these problems down. That's up to you. Let's go ahead and start, excuse me, with number one here. Now, please look what we know. Are you ready, students? Please watch this. Please watch this. Do you see how this angle here is congruent to this angle here? Now, we learned this about 4 or 5 days ago, guys. You're responsible for previous knowledge that was learned, okay? Let's just, I don't know what the angle is here, but this angle here is congruent to this angle here. Now, let's pretend this angle is 30 degrees. Remember what you learned? Whenever you have a central angle, and here's your central angle right here, see your central angle? Whenever you have a central angle, it's 30 degrees, that means the arc out here would also be 30. Now, I'm not saying it's 30 degrees. I'm just picking some number and throwing it out there randomly, okay? And if this central angle right here is 30 degrees, then that means this arc out here is 30 degrees. Do you see what I'm saying, students? Okay? So, look. What I'm trying to show you is if you have central angles that are congruent, then it makes sense that arc ED and arc AB are going to be congruent. They have to be congruent. They have to be, because their central angles were congruent. We learned that probably a couple of days ago, 3 or 4 days ago. So I'm going to put a mark in that arc and a mark there in that arc. Now, what did we just learn, guys? Come on, watch this. Did we not just learn that if an arc is congruent to an arc, let's go back to our picture and look. If an arc is congruent to an arc, then the chords that made those arc, that chord and that chord, will be congruent. So, if this arc ED is congruent to this arc AB, then that means, let me get a different color ink here, that means that this chord right here, there's the chord that formed the arc, that chord has to be congruent to that chord. That's what we just learned right over here. If an arc is congruent to an arc, then its two chords are congruent. So if this chord here has a length of 4 and this chord here is x, x has to equal 4. So the answer is 4. Now let's come over and take a look at this one. Please watch carefully, okay? Notice that I have, this will be a little more difficult, but let's take a look at this. Notice, now watch, here's my central angle. Do you see this? Right there and right there. And what is that angle? 90 degrees. Now look at this central angle in green. See this central angle right here and right here? Well, look, students, if that's 90, this has to be 90 right here too. So what I have is this. I have two angles. This angle right here is 90 degrees, and this angle right here is 90. So remember, when you have a central angle, that means arc FG has to be what? 90 degrees. And that means arc HG has to be what? 90 degrees. Look what you got. You've got the same thing again. You've got an arc right here congruent to an arc here. And what did we just learn in the previous page? We learned that when an arc is congruent to an arc, its corresponding chords are congruent. So here's, I'm going to change colors here. This chord right here, that's not the color I wanted. There we go. This chord right here is the chord that forms this arc right here. And this chord right here is the chord that forms this arc right here. So those two chords have to be congruent because their arcs are congruent. Remember, when two minor arcs are congruent, their chords are congruent. So what's the length of FG? 5. What's the length of HG? X plus 2. Well, they have to be congruent, so set them equal. X plus 2 equals 5. Now bring the 2 over and make it a -2, and x equals 3. There we go, not too bad. And now one more problem and we're finished. Let me go ahead and look a little closer here. Actually, I do apologize. I usually take some pretty good pictures and make sure this thing is, the pictures are usually pretty clear, but I do not have my book open, so let me quickly turn over to page 610. I carry my geometry book in my back pocket, of course. Just kidding. So if you'll look in your book, you're seeing right now this is 40 degrees, so this angle here is 40. And then, of course, we have x plus 10 right here. X plus 10, I think it says degrees. All right, now let's think this through for a second here, okay? This is going to be really, really, really interesting. I'm going to erase these numbers. You can look in your book and say this is this is a 40 and this is x plus 10. Now please, please watch what I do. I'm going to walk you through this step by step by step. If you'll look in your book, it's really hard to see on the picture here, but if you'll look in your book, the chord is congruent, and the chord, not the arc, the straight line is congruent. Look in your book and you'll see it, okay? If you didn't turn over to 610, you need to. Turn over to 610 and you'll see there's a little black line that's going straight across, guys, right here, okay? There's a little line going straight across right here and a little line going straight across here, and they're the ones that have the mark, okay? So what we have are congruent chords. We have a straight line and a straight line. They're congruent. Now, that goes back to part 1 here. If two chords are congruent, then their arcs are congruent. So let's go back and look. So I know if this chord here is congruent to this chord here, which it is, then it only makes sense then that, okay, students, I'm back. My computer every now and then crashes, and that's just what happens. So thankfully I was able to save the video part, and I lost some of the writing I had, but let's go ahead and pick up where we were. I was saying that if this chord here is congruent to this chord here, which it is, you can look in your book and see that, then that means this arc out here, this curved arc, is congruent to this curved arc here. So now I can say this arc is congruent to this arc. And to that, I'm just kind of joking with you, but to that you might say, okay, Mr. Earhart, big deal. It really doesn't help us. We're trying to figure out these angles. I know that, but remember something. Let me draw a circle down here for you. Please don't forget this, students. Please don't forget this. Look, when you have a central angle, if this is 45 degrees, then that means your arc out here is also what? 45 degrees. So if I have an arc out here that's 45 degrees, this arc is 45 degrees, this arc is 45 degrees. What does that mean this angle here is? 45. Oh, really? Well, what does it mean this angle here is? 45. So if this arc here is congruent to this arc here, then this angle here has to be congruent to this angle here. Okay, so that's what they're doing here. They're saying, look, if this arc here is congruent to this arc here, which it is, then that means this angle here, which is what? 40 degrees, has to be congruent to this angle here, which is what? X plus 10. So what we have is x plus 10 equals 40. Bring your 10 over and make it negative, and x equals 30. Now this has not been a very long video, but that does not mean that you don't need to watch it again. You might need to watch this 2 or 3 times and go over and over it until you really get it. Okay, that's what separates the A's from the B's. Unfortunately, sometimes the D's from the F's are the students who are willing to put in the work and say, hey, I've got to learn this, okay? And I hope you'll do that. Now, there is your homework, page 610, numbers 2, 4, 5, 9 through 14, 17, 18, and 20. Please get to work on that. You need to work until you're finished. It is due tomorrow. And if you have any questions, don't hesitate to call or email. Of course, the video that goes along with this would be geometry 11.4. This is a little different. I'm glad I thought of that. Homework part 2. Is actually what it's called. So I do apologize for almost forgetting that. This is the video that goes with that assignment, Geometry 11.4 Homework Part 2. Okay? Have a good day.